Hi everyone, how are you doing? So just to let you know, I released your midterm score on our Canvas system, and then later today I'm going to post the scanned copy of your scored exam, and then let me know if you have any questions. Okay, so last time we talked about how we could classify the state of the Markov chain, right? And the very first thing we talked about is recurrent and transient, right? Do you remember what it is? So for the recurrent state, if there is any possibility that you leave that state, never come back, that state is called transient state, right? If the state of the Markov chain is not transient state, it's got to be recurrent state, okay? And we also learned two states that communicate are said to be in the same class, right? That's a very simple concept. And we discussed how to determine the period of states of a Markov chain, right, with some example problem. And our discussion last time also includes a closed set, a minimum closed set. Okay, you remember? So once you get in the closed set, you can never ever leave the closed set, right? Keep in mind that. And we also talked about absorbing state. So a state which forms a closed set, that is, which cannot reach another state, is said to be an absorbing. Okay? So whenever you enter an absorbing state, we never leave that state. Okay? So let me give you a very simple exercise problem. Okay, so let's consider a very simple transition diagram. So we have, let's say this is state 1, and this is state number 2, and let's say this is state number 3. Maybe we have this transition and this transition, and then let's say this transition, and let's say we have another transition here, and we're going to have another transition 2 to 4, and let's have this too. Okay, so now let's see which of them are transient and recurrent and absorbing. So which of these 4 states are transient states? How about state number 1? Of course, if you take this route, then you were going to come back always, right? But the question is, what if we take this path? Can you ever come back? No, right? So state number 1 has to be transient state, right? The same for state number 2. Right? If you leave, there is no way you can return. Right? Also, if you leave, there is no way you can return. So both 1 and 2 are transient state, right? Which means 3 and 4 has to be absorbing and transient state, right? Is that correct? What if I add another? Let's say this is state number 5 and 6. So we have this. So state number 5 and 6 communicate. And okay, let's put this another transition here. So now, what about state number 5 and 6? They are recurrent, of course, right? So 5 and 6 are recurrent as well. Is that absorbing? No. Right? Because state number 5, starting from here, you can leave state number 5, right? So it cannot be absorbing. Is that right? Same. Starting from 6, you can leave. So state number 6 cannot be absorbing. Okay? So in this case, we have only 2 states, 3 and 4 absorbing. Although we have 4 recurrent states. Is that right? Any questions? Okay. So let's go back to the class slide. Let's see what happened. Why I cannot control. Okay. Okay. And the last time, we also talked about absorbing. And regardless of the type of the Markov chain, so for example, whether or not it is regular Markov chain or absorbing Markov chain, we still can use what is that Chapman-Kolmogorov equation to get the nth power matrix, right, of the Markov chain to reveal the probabilistic feature of the chain, of the Markov chain. However, for the case of absorbing Markov chain, there is a special method which is called absorption analysis for the analysis of absorbing chain. You remember this, right? So the absorption analysis involved with partitioning the given absorbing Markov chain into 4 different portions. Okay, identity matrix, and then zero matrix here, and then Q matrix, R matrix. Okay, keep in mind that Q matrix consists of only the transient state. Okay, and R matrix start from transient state and then end up with absorbing state. Okay. So once you have that matrix partition like that, then we should be able to answer for the following 2 questions. Okay? The first question is saying that starting from a transient state, how many transitions do we expect to spend in a given transient state before absorption takes place? Okay? The answer for the question is from E matrix, which is from this. And second question, saying that starting from a transient state, what is the probability that you end up in each of absorbing state? Okay? And the answer can be obtained from the A matrix, which is from this. Okay? So that's what we talked about last time. Okay, so now let's consider another example. So from this example, we're going to see how we could use absorption analysis. Okay. Okay, so let me read the problem description first. So General Motors has 3 auto divisions. They are A, B, and C, and served by an accounting and management consulting departments. And they desire to know what percentage of cost of the support departments should be allocated to each of the auto divisions. So the small table gives the fraction of the support given to each of the divisions. Okay? And here's the given information. Each year, it costs $63 million to run the accounting department and $210 million to run the management consulting department. And these costs are to be allocated entirely to the auto divisions, to the 3 different auto divisions, A, B, and C. Then the question is, how should this allocation can be done? Should be done. So in this case, we are going to model $1 of cost as a Markov chain, okay, with this given 5 possible states. The first state represents the accounting department, second state, management and consulting department, and then state number 3 and 4, 5 auto divisions, A, B, and C. Okay? And this dollar gets passed from one support department to another until eventually it gets absorbed by one of the 3 auto divisions. So we know that states number 3, 4, and 5 should be absorbing state. Does it make sense? Okay? Okay, now let me give you a couple minutes please try to build up one-stage transition probability matrix, P, using this given information. And I will get back to you in a couple of minutes. I don't know, something weird. Camera control. Okay. That should be okay. Okay, so let me draw the transition diagram first, based on the this given information. Okay, which is this. So we have 5 different departments, right? So let's say first one is accounting, and then this is consulting department, right? Consulting department, and then down here we have A, B, and C, different outer divisions. Okay, so based on the given information, accounting to accounting has to be 0.1, right? Accounting to consulting has to be 0.3, and then this is going to be 0.2, 0.2, right? And then this is going to be 0.2. Is that right? Starting from consulting, this is going to be 0.2. And then go to accounting department, it's 0.3, right? And what do we have here? Consulting to division 3, division C is 0.2. And then consulting to division A is 0.3. What else? Since we know that all three departments, ABC, absorbing state, this is going to be 1 each of them. Is that right? So based on this transition diagram, we should be able to construct the one-step transition probability matrix. So let's say there is P. Then we're going to have 5 by 5 matrix. Okay? So this is going to be 0.1, 0.3, and then 0.2 each. Right? 0.3, 0.2, 0.3, 0, 0.2, right? And then 1, 1, 1. All others are 0, right? Is that correct? Right? So how do we do the partition, matrix partition? It's going to be like this, right? So we have here identity matrix, we have 0 matrix, and where do we have Q matrix? Upper left, right? This is going to be Q matrix, which means this part becomes R matrix. Is that right? So what is the next step? We need to compute E matrix and A matrix, right? Do you remember the formula for E matrix? What is that? Identity matrix minus Q, and then take inverse, right? Because Q matrix in our case is 2 by 2. So our identity matrix also has to be 2 by 2, right? That's going to be 1, 1, 0, 0 minus 0.1, 0.3, 0.3, 0.2. Is that right? So what is this? 0.9 and then negative 0.3, negative 0.3, and then 0.8, right? And then inverse, sorry, here, so that inverse. So what is this? It's going to be 1 over AD. Those are 0.9, 0.8, so 0.72 minus BC, which is this, so 0.09, right? And then switch over here, so we have 0.8, 0.9, then put negative sign, 0.3. So this is going to be the E matrix. So what is this? Let me use my cell phone to calculate. Do you have? Okay. So 1 point, yeah, I have 1.26 98, and then 0.476, 1, okay. And then here 0.476, 1. 85? Thank you. So this is our E matrix. Since we have E matrix, now we can compute A matrix, right? A is E times R. So this is E, right? What is R? So here, 2 by 3 matrix is R matrix, okay? So we need to multiply those two. Can you give me the value for that? Okay, now I have 0.397 something, and here I have 0.254. Okay, I have 0.349. Down here, 0.524. Okay, now I have 0.095 and 0.381, something like that. Okay, is that right? Okay. Okay, so how do you answer for this question? How do you allocate this amount of money, $63 million, to run the accounting department, and then $210 million to run the management consulting department? How do you allocate this money to those 3 auto division department? So how do you answer that question? So what you need is, we just got A matrix, right? So what you need is just multiply 63 million and then $210 million times A matrix. Is that right? Because these are the support cost, and then these are the absorption probabilities. Right? So please multiply this value and then let me know what you got here. It's got to be 1 by 3, right? Because it's 2 by 1 times 2 by 3. I'm sorry, it's 1 by 2. 1 by 2 times 2 by 3 should become 1 by 3. So what is the first value? 135.05. So I'd say this is like $135 million. Okay? How about this? Second value then? 35.95. So it's approximately $36 million. How about the third value? 101.99. So it's approximately 102 million. So we've got the answer, right? So how do you report? So I'd say here, $135 million of the support cost should be assigned to division A. And this $36 million to division B. And finally, $102 million to division C. Is that right? Is that easy? Right? Okay. Okay. Now, let me give you in-class exercise problems. Okay. So in this example, we are going to help a mouse, okay, to find a good source of food. Okay? So let me give you a couple of minutes. Why don't you read through the problem description and then try to answer for those series of 4 questions first. Okay? So let me put up the information here. Okay, so this is the example in-class exercise problem that you are going to consider. And I'm going to also post our problem set, another problem set for the absorption analysis. So, and with a solution later on our Canvas website. So make sure you can do this. This is very easy to do. Okay? So here's the problem set that I'm going to post on our Canvas website later with solutions. Okay? And now we are going to work on these in-class exercise problems. Okay, so let's read the problem description first together. A red is placed in location number 1 of the maze, shown below on the left. So down here, right? So red is placed right here. The Markov chain model has been built where the state of the system is the location of the red after he leaves his current location. So this is the transition diagram that we can build based on this figure of maze. Okay? Because, for example, there is a block between 10 and 11, which means there is no direct connection from 10 to 11. Okay? The same, because there is a wall between 7 and 8, which means you cannot go from 7 to 8 directly, or vice versa. Okay? That's why you don't have any connection here. Now I understand how we come up with this transition diagram. Okay? And also, all of these transition probabilities are given. So based on this, you can compute the steady state probability distribution. Okay? And then also we can get the M matrix, mean first passage time matrix, okay, that we talked about earlier. So using all of this information, we want to answer for these first 4 questions, okay? And then we're going to move on to the part 2. Okay, so how do you answer for the first question? if we record the red location over a period of several days, which location do you expect to be visited most frequently by the rat? What? I'm sorry?
The steady state.
Okay, so we can use steady state probability distribution, right? Right, to answer for that question. So based upon the steady state probabilities, here the largest value occurs right here and right here and here, right? That corresponds to location numbers 3, 5, and 7. Okay? So I do say locations 3, 5, and 7 equally open. Is that right? Okay, so first question is very simple. How about number 2? The number of transient states in the Markov chain model. It's very easy. We just need to look at this transition diagram. So how many transient states do we have? Transient state. What is the transient state? If there is any possible way that you leave the state, never come back. Those are the transient. So for example, let's start from state number 10. You leave state. All the way. And then you come back, right? Is that right? Starting from 10, you go through every state and then come back, which means all of these 12 states are recurrent states. Is that right? None of these 12 states are transient states. Does that make sense? Okay, so be careful in that. Okay, how do you answer for state number, problem number 3, sorry. If the rat begins in location number 1, what is the expected number of moves required to reach location number 12? So it's been asking you expected number of moves required to reach location number 12, starting from location number 1. So which information you need to use? We need to look at M matrix, right? Starting from 1, and then you end up with 12. So this is our answer. Is that right? Okay. Now how do you answer for question number 4? If the rat begins in location number 1, how many locations will the rat visit before returning to his starting point? Again, we need to look at M matrix, right? So this time, starting from location number 1, you end up with location number 1 again. Okay. Now, let's move to part 2. Suppose that locations 11 and 12 contains food. It's really delicious food for rat. Okay? So that the rat does not leave when he finds food there in both locations 11 and 12. We made this assumption because we want to make both states, 11 and 12, becomes absorbing state. Okay? Now, this is going to be our transition diagram. Okay? New transition diagram. Only the difference is this part, right? 11 and 12. Okay? Because now we are assuming that 11 and 12. Both states are absorbing state. Okay? So based on this absorbing Markov chain, we can modify this P matrix a little bit, and then we do the matrix partition. After that, we end up with these two matrices, E matrix and A matrix. Okay? Of course, this E matrix is from I minus Q inverse. A is E R, right? Now, we should be able to answer for the following 4 questions. Okay, number 5. If the rat begins at location number 1, what is the probability that the rat finds the food at location number 11 first before the food at number 12, location number 12? So, how'd you answer? So we need to look at absorption probability, right? Which is A matrix. So we need to look at A sub starting from location 1, end up with location number 11, right? Which is this, 69%. Is that right? Simple. How about number 6? What is the expected number of times that the rat returns to his initial location after finding food? Okay. So in this case, we need to look at E matrix. And then that's going to be E11. Okay? What is that? 4.07. But in this case, you got to be careful. In this case, this value 4.07 also include the initial visit, okay? Because it started from location number 1, right? So in this case, you need to subtract by 1, okay? So the answer should be 3.07, not 4.07.
The one that's come from the entity matrix?
What?
Why we need to subtract that one?
Because it started from initial location 1, which is same as the ending location. Okay? Okay, how about number 7? If the rat manages to reach location number 7 before finding food, what is the probability that he first finds the food at location number 11? This is also very similar to question number 5, right? We need to look at the absorption probabilities. Now starting from 7, and then end up with 11, right? So we need to look at this, right? 79.3%. Okay, so this is the last question, number 8. The number of transient state in this Markov chain model is how many? Since we have 12 in total, we know that 2 of them are absorbing, which means the other 10 has to be transient state. Okay? So we have 10 transient state. Okay. How do you feel? Is that very easy? Easy to do? Of course, the key thing is how do you get this transition matrix, right? Beforehand, how do you define the state of system? That is the most important step, I'd say. Okay? Once you have those information, all the rest steps are pretty much the same. Okay? Of course, since we are dealing with big, huge matrix, 12 by 12, definitely we need computing power to get this information, right? But if you are really good at computer programming, then this is not a problem at all. Okay. Okay, so this is all for today. Like I mentioned, if you have time, please make sure you do the problem set that I provided you earlier. This is very easy to do, okay? But I just want to practice the absorption analysis, and then how do you determine recurrent and transient absorbing states, and the classes as well, okay, in this problem set. Okay, thank you very much. Bye-bye. Okay, Raman, so